Hi students, in this video we will talk about factorizing trinomials. So what I mean by trinomials is any expression which consists of three terms. Okay, so any expression which is consisted of three terms and the biggest power is 2. So the general form would be f of x is equal to ax2 plus bx plus c. As you can see here, the biggest power is 2, and then there are three terms, 1, 2, 3. This one is a quadratic trinomial expression. Okay, and let's see what I mean by quadratic trinomial. Quadratic refers to the biggest power, which here is 2. So whenever the biggest power is 2, we call it quadratic. Trinomial refers to the number of terms. That means there are 3 terms, and it's an expression. Okay, so here let's talk about the leading coefficient. There is another term I want you to, get familiar with, leading coefficient. Here, the leading coefficient is A, or in other terms, it is the coefficient of x squared. Okay? So, when we're discussing about factorizing trinomial, we will consider two general categories. First, when the leading coefficient is 1, and then the other category is when the leading coefficient is not 1. Okay, for a start, let's talk about when the leading coefficient is 1. That means, let's say f of x is equal to x squared plus bx, right, plus c. So we want to actually factorize this expression into two brackets, okay? So we want to factorize it in two brackets, which are x plus m and then x plus n, okay? So this expression is factorized in two brackets. And here we have to find, because the x is the repeating factor, okay, here we have to find m and n. M and n. These are the two factors, these are the two parameters which we have to find. Let me give you an example. So let's say I have x squared plus 5x plus 6. And I'm asked to factorize it. So I just make two brackets here, and then I'm looking for two numbers, which I add them together, I get 5, and I multiply them together, I get 6. Okay, what are these two numbers? It's easy, 2 and 3. So these two numbers, when they're added together, they give me 5, and when they're multiplied, they give me 6. Right? That's as easy as you can see. So when we have a quadratic trinomial with the leading factor of 1, we just rearrange the expression. It's better to rearrange it not to get confused. Then we have to look for the constant. So the coefficient of x is the sum of the two parameters, and the constant is actually the sum or the product. Okay, now let's have a chat about what is actually factorization. As I mentioned in my previous videos, factorization is the process by which we go about determining what we multiply to get the given quantity. That means like this expression can be rewritten as product of another two expression. Or in other terms, if these two are folded back or multiplied together, we will get this expression, exactly the same expression. Okay, let's do another example. So the next example would be x squared plus 2x and then minus 15. So here again, we have a quadratic polynomial or trinomial. That means the biggest exponent is 2 and it's consisted of 3 terms. And we want to factorize it into 2 linear expressions. Okay, so first of all, we have to make sure that this expression is written in order from the biggest power to the lowest power. So power 2, power 1, and 0. And then here, the leading coefficient, which is here, is 1. So the leading coefficient is 1. Let me write it down. Leading coefficient is 1. So we can simply say, I'm looking for two numbers, which I add them, I get 2. And if I multiply them, I get negative 5. And negative 15. And I believe one of the numbers is negative 5 plus 5 and negative 3. Because if I add these two numbers, the sum would be 2. And if I multiply them, it would be negative 15. So here I would say x plus 5 and then x minus 3. This is perfectly equal to this one. That means if you multiply these two after simplification, you will exactly get this one. Okay, let's give it a try and see if it's correct. So here, x will be multiplied by x. So the answer is x squared. Then x is multiplied by negative 3x. And then from here, like the second term would be multiplied by all the terms in the second bracket. So 5 times x and then 5 times negative 3. Okay, and now let's simplify by adding or subtracting the like terms. So here that would be x squared 2x minus 15 and plus 2x minus 15. And if you compare these two together, you will see that they are exactly the same thing. Okay, so actually, whenever you're not sure about your answer, or if you want to make sure or confirm that your answer is correct, you can simply multiply these together and simplify, and then see if you can get the original expression. This is how you can always check your answer and make sure you got it right. Okay, okay, let's do a recap. Here we have a trinomial, that means 3 terms, quadratic expression. What I mean by quadratic, that means the biggest power is 2. So here we have an expression and the operation in between is either plus or subtraction. And I want to factorize it in 2 or more brackets. Here, if we have power 2, like if the biggest power is 2, I can finally break it into 2 brackets, which each of these brackets is a linear expression. We discussed in the first part of the video, if the leading coefficient, that means the coefficient of x squared, if the leading coefficient is 1, we just have to look for 2 numbers. We just have to find 2 numbers. If we add them together, we get the b, and if we multiply them, we get the c. Okay, now in this part of the video, I want to show you how we came to the conclusion that m plus n should be b and m multiplied by n should be c. So here we're actually talking about the concept or the rationale behind it, right? So this is the original quadratic function that you have, and this side This is the general form of your, let's say, um, factorized expression. So here, I know that if I multiply these two back, if I multiply these two together and simplify them, I should get exactly the same answer. Okay, so that means if I multiply x by this and then m by this, if I simplify, I should get exactly the same thing. Let's do it together. So x multiplied by x is x squared, x multiplied by n x, then m multiplied by x is mx, and then here the last term, m multiplied by n is mn. Okay, this is the result of multiplying the two brackets together, and it must be equal to x squared plus bx plus c, right? As I just mentioned during the class, when we have two expressions, right? When we have two expressions, each at one side of the equal sign, if we want the two expressions to be exactly the same, that means we have to make sure the coefficient of each um, term is equal to the coefficient of the similar term on the other side. So here, if I consider x squared here, the coefficient is 1, and on this side, if I consider x squared, the coefficient is 1 again. Now on this side, if I consider x, the coefficient would be n plus m, right? N plus m, and on this side I would have b. Okay, and from here I can just come to the conclusion that b, which is the coefficient of x, should be equal to m plus n. Now let's compare the constant at both sides of the equal sign. So here our constant is m multiplied by n, and on this side our constant is c. So again, I come to the conclusion that m multiplied by n must be equal to c. Okay, and now you can compare this with this one. And from here, you could realize how we came to the conclusion that the coefficient of x must be the sum of the two unknown parameters, and the constant is the multiplication or the product of the two unknown parameters. This part of the video actually, this part, shows you how it shows you the concept behind it. And for you guys, it's very important at least to revise or to learn the concept, because when you're dealing with more complex problems, you can generalize the concepts into bigger problems. Now, the next example I'm going to give you is x squared plus 7x plus 10. And here the leading coefficient is again 1. So I open up two brackets. I write down the x. And here I'm looking for two numbers, which we add them, we get 7. The same two numbers, if they are multiplied, I get 10. So 5 and 2. Right? Now, let's do another example. Okay, the other example here is negative 2x plus x squared minus 24. Okay, now I still have a trinomial. The biggest exponent is 2, so it's a quadratic, and I'm asked to factorize it. So my suggestion to you guys, it's always try to rearrange it from the highest power to the lowest power. Because it would make more sense. And then it will later on, when we are dealing with higher orders, it helps you to factorize it like much more faster. So let me rearrange it from the highest term to the lowest. And as you can see here, then I'm looking for two unknown parameter, add them together, -2, the same two. If I multiply them, I should get -6. So I would say I can come up with -6, and I would say 4. And for like definitely if you multiply them back after simplification, you should get to the same answer. This is 100%. And to let you know that this is the only combination possible. No matter what solution you pick, okay, what method you pick, you have to come to the same, to this exact combination. Okay? Okay, now in this part of the video, we want to look at the same identity from a different angle. So let's say x plus m multiplied by x plus n, and we just saw the answer is x squared m plus n multiplied by x plus mn, right? Okay, now I want you to consider the same identity, but here we will look a little bit more deeper. So if you take a look at this expression here, you would see that x squared, okay, the square root of x squared is actually repeated in both brackets. So we have a repeating term, and I called it RT. This repeating term is happening in both brackets, exactly the same, right? But we have another two term, okay? We have another two term which are not repeating, right? These two, M and N, right? I call them non-repeating terms. Non-repeating terms. Okay? So repeating term is added to one of the non-repeating terms in one bracket. In another bracket, the repeating term is added to the second non-repeating term. I want you to consider this identity from this perspective as well, because this is the logic or rationale behind factorizing trinomials, which their leading factor is not 1. I will continue the trinomial which do not have their leading factor which their leading factor is against 1 in the next video. See you soon.